So to use Newton's laws, we need a good way to represent forces in a diagram. So to show you how to do this, we'll use an example of a physics textbook sitting on a table. And so the textbook is sitting there and the force of gravity is pulling down on it. And it turns out that there's also the table exerting a force upwards on it. So there's two forces here, one pulling down and one pushing up. And to represent this in a simplified diagram, what we do is draw what is called a free body diagram. And in one of these types of diagrams, we represent the object with a single dot, and we don't draw any of the surroundings. So we don't draw the table, for example. And then we draw all of the forces acting on that object coming from the object. So we have the force of gravity pointing down and the force from the table pointing up. That was a one-dimensional example, right? The forces were only in the up and down direction, but we can also draw free body diagrams in 2D. So here's an example of a box being held up by two wires. And to draw its free body diagram, we have the force of gravity pulling down, and we also have the force from the two wires pulling up and to the right and pulling up and to the left. So we can draw those. To make things easier later, we can also draw the components of those forces along the x and y directions, usually with a dotted line. So those would then be labeled F1x, F1y, and so on. Doing this by adding the components into the diagram makes it easier to apply Newton's first law, and later you'll see it also makes it easier to apply Newton's second law. Because we need to use the components when we do our vector addition, this way we have the components very clearly there. So summing the forces is straightforward now. All we have to do is look at which ones should be added and which ones should be subtracted, and we can just write down what the sum of the forces is. Here, the x components are just f1x minus f2x, assuming we say that to the right is positive. And in the y direction, we have f1y plus f2y minus the force of gravity. And then if we're using Newton's first law, we can check if these all add up to 0 or not. Okay, so Newton's second law then is that the acceleration of an object is equal to the total force on that object divided by its mass. So we can show the equations for that. The acceleration vector is equal to the force vector divided by the mass, or you might have seen it more commonly shown as the total force is equal to the mass times the acceleration. So when we apply Newton's second law in 2 dimensions, we have to break it up into components, just like we did when we did kinematics. So the acceleration in the x direction, or the x component of the acceleration, is equal to the total force in the x direction divided by the mass, and the acceleration in the y direction is equal to the total force in the y direction divided by the mass.